Given f of x equals 2x minus x cubed, we're asked to find the slope of the tangent line at the point at -2, 4, and the equation of the tangent line at the same point. To do this, we'll first find the derivative function using the limit definition of the derivative shown below, and then to find the slope of the tangent line at the point -2, 4, we need to evaluate the derivative function at x equals -2, and then once we have the slope of the tangent line, we can find the equation of the tangent line using the slope as well as the given point -2, 4. Let's begin by setting up the limit definition of the derivative. F prime of x is equal to the limit of the difference quotient as h approaches 0. The difference quotient is f of the quantity x plus h minus f of x all divided by h. To find f of the quantity x plus h, we substitute or replace x with x plus h in the given function, which gives us 2 times the quantity x plus h minus the cube of x plus h minus f of x, which gives us minus the quantity 2x minus x cubed. We do need the expression 2x minus x cubed in parentheses so that we're subtracting the entire function. All this is divided by h as h approaches 0. Notice in this form we cannot perform direct substitution to determine the limit, because if we did, we'd have division by 0. So now we need to expand and simplify the numerator. Distributing 2, we have 2x plus 2h. And now we need to cube the quantity x plus h. There's a couple ways we can do this. We know we have 3 factors of x plus h. So we could multiply the first 2 binomials and get x squared plus 2hx plus h squared, and then multiply by the last factor of x plus h. So while this will work, let's review how to use Pascal's triangle to more quickly cube the quantity x plus h. First, if we're cubing the quantity x plus h, the first term will have 3 factors of x. The second term will have 2 factors of x and 1 factor of h. The third term will have 1 factor of x and 2 factors of h. The fourth term will have 3 factors of h. And now we can use Pascal's triangle to determine the missing coefficients. So we start with a triangle of 1s. For the next row, start with a 1. For the middle number, we add 1 and 1, which gives us 2, and we end with a 1. We do this one more time. Begin with a 1. 1 plus 2 is 3. 2 plus 1 is 3. And we end with a 1. Starting with row 0, we have row 0, row 1, row 2, row 3. These are the missing coefficients when cubing the quantity x plus h. So the cube of the quantity x plus h is equal to 1x cubed plus 3x squared h plus 3xh squared plus 1h cubed, which would be the same result if we multiplied here and then simplified. But we are subtracting the cube of the quantity x plus h, so we need to subtract the expression in parentheses. And then we still have minus 2x, and then minus negative x cubed gives us plus x cubed, all over h. And now we remove this last set of parentheses and simplify the numerator. We have 2x plus 2h minus x cubed minus 3x squared h minus 3xh squared minus h cubed minus 2x and plus x cubed. And of course still all over h. And now let's simplify. Notice we have 2x minus 2x, that's 0. We have negative x cubed plus x cubed, that's 0. We have 4 remaining terms in the numerator, but notice all of them contain a factor of h. So in the next step, we'll factor out h from the numerator. Factoring h from the numerator, we have h times the quantity 2 minus 3x squared minus 3xh minus h squared all over h. Notice if we distribute h in the numerator, we do have 2h minus 2x squared h minus 3xh squared minus h cubed. The reason we wanted to factor is now we can simplify out the factor of h in the numerator and denominator. H divided by h simplifies to 1. So now we're left with f prime of x is equal to the limit of 2 minus 3x squared minus 3xh minus h squared as h approaches 0. Well, as h approaches 0, 3xh approaches 0, and so does h squared. The limit is equal to 2 minus 3x squared. The derivative function f prime of x is equal to 2 minus 3x squared. We can determine the slope of the tangent line at the point negative 2 comma 4 by determining f prime of negative 2, which is equal to 2 minus 3 times the square of negative 2, which is equal to 2 minus 3 times 4, and 2 minus 12 is negative 10. So now we know the slope of the tangent line at the point negative 2 comma 4 is m equals negative 10. Now that we know the slope of the tangent line, we can determine the equation of the tangent line, again at the point negative 2 comma 4. And we can use either point slope form or slope intercept form. I'm going to go ahead and use point slope form, which is the form y minus y1 equals m times the quantity x minus x1, where we know m is equal to negative 10, and our point is negative 2 comma 4, which means x1 equals negative 2, y1 equals 4. Which gives us the equation y minus 4 equals negative 10 times the quantity x minus negative 2. Simplifying, we have y minus 4 equals negative 10 times the quantity x plus 2. We can use this as the point slope form of the equation of the tangent line, but let's also solve this for y and write the equation in slope to intercept form. So we'll distribute negative 10 and then add 4 to both sides. Distributing negative 10 gives us negative 10x minus 20. And then we add 4 to both sides. Simplifying, we have y equals negative 10x minus 16. The equation of the tangent line is y equals negative 10x minus 16. And let's look at this graphically. We have the graph of the cubic function in red. The point negative 2 comma 4 is this blue point. We just found the equation of this blue tangent line where the slope is negative 10 and the vertical intercept or y-intercept, which we can't see, is negative 16. I hope you found this helpful.